Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable session. This particular faculty roundtable session is with the Sonny Astana Department of Civil and Environmental Engineering, and we have some fantastic faculty here with you to be able to explain this discipline, display the curriculum, and help answer your questions. My name is Paul Ledesma. I'm the Executive Director of Undergraduate Admission here for the Viterbi School, but you will not hear a lot from me today. I am just here moderating the conversation and helping our faculty get to know you. So without further ado, I'm going to let them introduce themselves, and then I'm going to come back and tell you how today's session is going to run. We're going to start, just because this is the order on my screen, we'll start with Professor Smith.
Hey everyone, I'm Dr. Adam Smith. I'm an associate professor of environmental engineering, and I'm also the director of the environmental engineering program in our department.
Professor Becerik.
Hello, my name is Burcin Becerik-Gerber. I am a professor of civil engineering. I've been with our department for 16 years, and I'm also the current department chair. Very nice to meet you all.
Professor Nweke.
How you guys doing? My name is I'm Professor Chukwuebuka Nweke. I'm an assistant professor here in the Department of Civil and Environmental Engineering. I've been here for 2.5 years, 2 years, a little over 2 years, and it's great to meet you all.
And Professor Ghanem.
Good afternoon. My name is Ghanem. I'm a professor in this department, Civil and Environmental Engineering, and I've been here for almost 20 years. Nice to meet you all. Looking forward to talking to you.
Fantastic. So this is how today's session is going to go. The first half of the program, I'm going to be leading the discussion with a set of questions that will help you understand what everything is all about in civil and environmental engineering. And then in the second half of the program, I'm going to turn the reins over to you as the audience, where you're going to be able to submit questions into the Q&A feature and then also moderate those questions on your own. You're all going to upvote, make it a democratic process, and the most popular questions will be answered first. So we'll have that opportunity towards the second half. Right now, it has been disabled. There are no questions coming in from any of you right now. So sit back, relax, and enjoy the overall session. This is an opportunity to get to know the program. And then when I open up the Q&A, I will definitely let you do that at that time. But for now, let's get started with the first question, seemingly the most simple question in the overall session, but likely the most complicated when it comes to answers, which is, what the heck is civil engineering? What the heck is environmental engineering? Professor Becerik-Gerber, would you like to give that a shot to kick us off, and then people can jump in? And I'm sure Professor Smith wants to jump in with more environmental heavy stuff.
Well, they are, thank you, Paul. I'll get it started. In my opinion, they're the best two engineering degrees that exist, because they are both fundamentally important in our daily lives. So civil engineering is the discipline that designs, constructs, and maintains the physical environment, the built environment. So anytime that you travel on a highway, or you're in an airport, or you're in an office, so all of that infrastructure is designed, constructed, and operated by civil engineers. It is called civil engineering because it is the oldest engineering degree after military engineering. So there used to be military engineering that does everything related to military, and then civil engineering that helps military to get places. So I'll leave the environmental engineering definition to Dr. Smith, but I'm sure Dr. Nweke and Ghanem have also their own perspectives.
Adam, you want to jump in?
Yeah, sure. So environmental engineering, I like to think about it as engineered systems that are at the interface between the built and natural environment. So we're protecting the environment from various waste that we might produce, and then in the inverse of that, we're using resources from the environment in a way that protects public health. So in general, it's extraordinarily interdisciplinary in terms of the engineering that's involved in environmental, and then also the chemistry and biology that are required within our discipline. And so, like, traditionally, it's mostly focused on water and air, but we've really expanded in the past decade or two to encapsulate areas like climate modeling, carbon capture, renewable energy systems, agricultural systems, and we have more direct ties with public health now, especially after the pandemic.
Any other thoughts that you all want to jump in on? Obviously, it's incredibly broad, but anything we might have missed here?
Just to piggyback off of the civil engineering side. So as stated, it's pretty much the best and the original engineering. And we deal with, and it's actually not as simple as meet the eye, because it's very complex. There's a lot of components to it, civil engineering. You know, you have civil engineering, you have, in addition to the fact we have environmental, we have the structural component of civil engineering, we have the transportation component of civil engineering, the geotechnical component of civil engineering, which is my specialty, and I believe one of the initial things that are most important, because they deal with the ground, and you have, and there's a facet that continues on and on after that. So there's a lot that goes into it. So we deal with problem solving and buildings, and we are stewards of the public, because what we build has to stand, and you have to use it. So we're kind of agents of the public.
That's great. Thank you. Let's dive into how this is kind of worked out in the undergraduate curriculum. You know, our students are coming from a high school perspective. Civil engineering is not something that's ever taught in a high school curriculum. You know, environmental science might be. And so can we explain what the undergraduate curriculum kind of looks like from the top down? What is that arc that students go through? And then maybe as we can talk about civil engineering, we talk about environmental engineering, and then maybe you all can jump in with, you know, maybe detailing out courses that you particularly teach and how a college class is structured.
Sure. I can maybe take a stab at that question. We have 2 undergraduate degrees, Bachelor's of Science in Civil Engineering and Bachelor's of Science in Environmental Engineering. And we have 6 different tracks in the civil engineering undergraduate degree. And those are with a focus on environment, with a focus on construction engineering and management, a focus on water resources, a focus on building science, and a focus on structural engineering. So depending on the area that you want to specialize, that you can be in one of these tracks in civil engineering and develop more skills and background in those areas. I'll just talk a little bit about building science, because it's a very interesting degree that brings together architecture and structural engineering. So those students take classes from School of Architecture as well as our department, Civil and Environmental Engineering. So they understand the design side of structures, as well as they're able to do all of the calculations and the engineering side of buildings. So they do, I know this is not the question, but they can go after that to either to architecture and engineering. From my experience, I see more of them going into engineering than architecture. But I just wanted to highlight that one, because it is a very, very unique program. I will give the others to talk about the other tracks and our undergraduate curriculum, but I also wanted to go back a little bit and piggyback on something Buka said, which is the discipline is very interdisciplinary, both civil and environmental engineering, that requires collaboration of multiple disciplines, and we all have slightly different backgrounds. For example, I have architectural engineering background. We have faculty members with mechanical engineering background, multiple of them. Roger is one of them. It does give you the fundamentals, but then after that, what you do with those fundamentals are quite varied. If you look at our department's website, we have our research areas. I know we're talking about curriculum, but research is also important in the department, because that influences what we teach, right, in the classroom. And we don't organize ourselves around traditional civil and environmental engineering groups like geotech, transportation, structural, like Buka mentioned, but we have 5 different areas that we think are more future looking. And those are engineering for extreme habitats. So think about extraterrestrial construction, right? Or think about deserts and or cold environments, offshore structures. So we have to build in those kind of extreme habitats more and more. Engineering for disaster resilience. Buka is an expert in this. Earthquakes to tsunamis and hurricanes, and you name it, right? You see a lot of extreme events more and more frequently. engineering for transport service systems. We mentioned transportation, but we focus on autonomous vehicles and control and optimization, and new modes of also transportation, right? And you're very familiar with that, like Ubers and such. Engineering for environmental stewardship, that's where many of our environmental engineering faculty focuses, but also civil engineering faculty also focuses. Like myself, I focus on energy efficient buildings, for example. And last but not least, engineering for urban livability. So we do see a lot of population growth in the urban areas. So our goal in our department is, how do we make our urban life better? How do we increase the quality of life by thinking about adaptability and joy of life? I'll leave there. I talked too much, and I'll leave the others to also answer the curriculum question.
Adam, environmental engineering as a curriculum, what kind of classes do they take? What's the work that they're going to do?
Yeah, let me explain. We have two options, two different tracks for the environmental engineering curriculum. And so one option, like Burcin mentioned, is we have our BS in environmental engineering. So if you are super invested into environmental engineering, that's probably the track for you. On the other hand, we have a BS in civil engineering with an emphasis in environmental engineering. So that provides a stronger foundation in your civil engineering courses, and then still many of our introductory environmental engineering courses, but you don't get to take courses that take it a step further, like organic chemistry or contaminant transport in the environment or additional air courses. And I would say for students who might be interested in environmental engineering and really unsure which track to take, fortunately, the two different tracks are identical for the first 3 semesters. So you have a lot of time to kind of explore some of our introductory courses that give you a good flavor of civil versus environmental and decide which one you ultimately want to complete your degree in.
Yeah, I think that's an important point as we dive into the specializations and emphases. And a lot of high school students believe that they have to have this all mapped out and figure out exactly where they want to go. And it's not that way. Buka, do you want to jump in here? I think you're about to say something. I'm sorry, Adam, go ahead.
Oh, I was just going to say, one of the great courses we have that you take your first semester is an introductory course where, for environmental engineering, at least we have the same thing for civil, but for environmental, it's 6 or 7 different faculty members. You get to meet all of the faculty throughout the semester, and then you get to learn about all of their various topics of environmental, so you can really get a good sense right away if environmental is for you.
Yeah. So on the civil side, as Dr. Becerik mentioned earlier, there's a couple of tracks you can go. We have the general track, we have the construction track, the structural track, the building science track, the water, and then you have the environmental track. So specifically on the general and the construction and the structural track, these tracks are fairly similar in the beginning, which is classes you'll be taking mostly in the beginning are your math, physics that you're going to need for the foundation for your going forward. And after that, at about the end of your second year, beginning of your third year, you start to see classes that either push you, like that will give you a flavor of multiple different avenues. And then by the end of your third year, the beginning of your fourth year, then you can pick the kind of specialty you can dive into. So there's flexibility in those things. But the main thing you'll be taking primarily will be the math and physics. And as you get further along in your studies, then you can specialize. You know, if you want to focus on structural, then you will take the focus on the structural classes that focus on structural dynamics and tall buildings, you know, wood frame structures, bridges, the extreme loadings, earthquakes, tsunamis, things of that nature. If you want to go into construction, you're going to focus on the buildings, but you're also going to learn more about things that are pertaining to construction, which is, you know, procurement, you know, dealing with I forgot what it's called, but dealing with what's the word I'm looking for? It's
Permitting.
Permitting and pretty much all this that goes into construction, right? Learn how to build a building, because you can design the building, you can do the analysis, but you have to build a building, and building the building is a whole different paradigm in regards to that. And the water resource, you can take the water classes where you deal with either water structures and things of that nature. And the building science is similar, and you get the architectural flavor of that. So you get to see from inception to completion. So all these classes are different. What I will say about the curriculum, particularly for us at USC, that makes us so special is that, and Professor Becerik mentioned earlier, is that everything is so interdisciplinary. So the flavors that you usually get, that you would get in a traditional university where it's just broken into different silos, we don't have those flavors we have here are a bit enhanced because you can take the structural classes and be interested in building science to understand, okay, I want to know how to build it. I want to know how to build the building, but what does the concept look like of conception, right? How do I look at the Burj Khalifa, right? How do we conceptualize Burj Khalifa? Why does it look the way it looks? Is it because somebody just likes that design, or is there functionality with it? Or you can go into construction and understand, okay, I know how to design this, I know how to build it, but what is it going to take to build it? How much money am I going to have to put together? Who do I hire? How do I stage? How do I optimize? How do I schedule? These things are important. The same way you go on your day-to-day lives and you schedule your lives. You know, you just don't wake up in the morning and, you know, and all of a sudden your shoes are on and your shirt is on and you just walk outside. No, there's steps to that, right? You have to brush your teeth, eat breakfast, put your shoes on, tie your laces, and keep going. So those are the steps you have to. So here at USC, everybody is so interdisciplinary and we're tied into it. So when you get here, you're not just going to get a traditional civil engineering degree. You're going to get a very enhanced civil engineering degree that's you can get a flavor of everything. Even from the environmental and structural side, there's a lot of things that go along with that. Because, you know, just because a building creates waste, if you can optimize that, you can all of a sudden learn how to do different things. So if you want to understand how people interact with buildings, Professor Becerik deals with that. You know, there's an active shooter in the area, right? What's the best path to go in the building? We're doing stuff and we're teaching things about that here to optimize that and help advance society. So that's kind of the goal, kind of building our goal here is to teach you about the next utopia, essentially. And that's what our curriculum is focused on.
Paul, you're muted.
Thank you for letting me know. Speaking of optimization, I want Professor Ghanem to jump in here. You know, I know he teaches a class, you teach a class in risk and decision analysis. Can we talk a little bit about what that class covers and how that class is structured?
Yes, that class actually is used to be one class taught to seniors. Now it's split into two parts. So students are introduced to data science and statistical analysis as sophomores in statistics class. And that knowledge is used in subsequent courses through junior and senior years. And in the senior year, there's a conclusion to that course, if you want, in the form of a probability course that brings the ability to do data analysis and statistical thinking to solve more complex problems in engineering. For example, how to deal with, and not just from a data perspective, but from a logical perspective, how to deal with an evolving climate, for example, how to deal with the fact that we have incomplete measurements on the properties of concrete or wood or soil, and what are the consequences of this incompleteness in our understanding on design probabilities of failure. So as part of that, students are introduced to ideas of optimization, probability, and statistics, as I mentioned. Now, what was I was going to add something else. Yes, I would like to follow up on what Buka said. We build actually, and I have a high school son now who's starting to think about going to college, and civil engineering is on his radar screen. And I've been thinking a lot about the transition from high school to freshman in college and civil engineering. And this is what how I have been talking to him about the transition. You take your physics knowledge that you're learning in high school, and you already know Newton's theorem, for example, F equals ma. You know your basic calculus, and the question is how to, well, what they will learn is how to extend this basic knowledge to the design of complicated structures like buildings and bridges, and it's not much more complicated. It's just a matter of being methodical and extending what they already know in a very principled manner. And we are very good here at, we have mastered the art of, the art and science of progressive knowledge acquisition, to take them from the knowledge they have in high school through the requisite steps to the point where they can design with full confidence and full reliability very complicated structures that adhere to acceptable and required norms and codes of practice, such as buildings and bridges and foundations, and that's on the structure side, and other systems on the environmental side.
Great, thank you so much. Let's talk a little bit about where you see students going after our program outcomes. You know, students go on into work, the grand majority go straight into industry, and then probably about 25 to 30% go on into grad programs. Can you give us some, what types of companies are they going off to working at? Where are they doing? What kinds of grad programs are they going off and working at? Just students that you know of? Adam, you want to get started?
Oh, sure, I can. Yeah. On the environmental side, I would say many of our graduates, just with the BS degree, they'll go out into consulting engineering firms. That's probably the most common path. But alternatively, many of our graduates also work at utilities, whether it's like a drinking water utility or a wastewater utility, an air quality monitoring board. And then other options include governmental agencies like the EPA is a good example.
Roger, you wanted to say something, go ahead.
Well, we have quite a few students who also end up in graduate school. And we encourage the scientific curiosity on the part of all our students, and those who are inclined to pursue careers in scientific research. We also have good pathways for them to do internships, either with us or with other labs all over the world, as well as labs at the national, opportunities at national laboratories in the US as well. So we encourage students to fulfill their potential, be it at in the industrial sector or the research sector in the academia and otherwise.
And I'll cover the construction because I'm very familiar with that. Many of our graduates go to top 10, top 20 construction companies, Swinerton, DPR, AECOM, Hensel Phelps, Hathaway, Dinwiddie, you name it, right? You can look at ENR, top 10 or top 20 construction companies. I think we have sent our students to all of those. As well as Adam mentioned, engineering companies like Arup, right? That's one company that comes to my mind that we sent our graduates, along with other companies like Arcadis and consulting firms. But those are the more traditional paths. Recently, I actually got a call from SpaceX, and and they told me that they need more civil engineers because they are building nonstop. They're building almost like cities and towns and cities, right? For them to be able to build what they're building, they have to have campus. And for that, they were actually calling our department to say, can you send your students to us, to SpaceX? But there are other tech companies that employ civil and environmental engineers as well. I have actually students who work for Apple and Google and Meta and you name it, because all of those companies also have large infrastructure needs. So you don't have to think about this from like traditional engineering, construction, or environmental engineering perspective. Think about it like who needs infrastructure to be designed, constructed, and built.
Yeah, on the civil engineering side, it's very similar to what has been said. More often than not, a lot of our students end up going into consulting when they come out of the bachelor's degree, and these are pretty good consulting companies, particularly in LA. LA has, just like many of the big cities, but particularly Los Angeles, we have a lot of tall buildings, so very, very exciting structures, very fascinating structures. So, and we have a lot of, sports arenas that are being built here and there. So people like AECOM that's building the Clipper Stadium, which I just visited with some of my students this summer. people such tall people like Wood, URS, building tall buildings left and right, skyscrapers here and there. And people also, for instance, like similar to SpaceX, they have the Boring Company. So these tunnels that go through all these new fascinating technology that you see, the new high-speed road that's being built. These are all companies that our students go to. So it's just a matter of when you get here. Once you're done, you're gonna have pretty much your choice of where you want to go to, depend on what you're looking for. So there's a plethora of places you can go in the tech industry as well. Civil engineering is not necessarily just civil engineering. We're problem solvers, so we solve problems, and that's why these tech companies like to hire us. So when you come here, we're going to teach you the best way to solve these problems. You can have the best skill set on solving these problems, and when you leave, there'll be people. You have lots of suitors for your skill set. So,
all right, thank you so much. At this point, for all of our guests, this is an opportunity. Now, I have one more question that I'm going to ask to our panelists, but while I'm doing that, and while they're answering, you could start throwing in questions that I will then moderate. You can go to the Q&A button at the bottom of your screen there, and you can type in questions, and type in as many questions as you like. After you've added a couple questions, or maybe you're a little too shy, you can just start upvoting the questions. And so we need lots of questions. We need lots of votes. And the most popular questions we'll get to one by one, and I will moderate those and kind of take it down one by one. So faculty, just stay with me. Don't worry about the Q&A. I'll take care of it. But if we can get all of our guests to start typing in questions, I'd appreciate that. While we're waiting for them to get their questions in, my final question that is coming from me is to see if you have your crystal balls out. Can we look into the future? What are you excited about in the future of your discipline, of your area? What do you think is out there? Buka, do you want to kick us off with this one? What you're excited about in the future of civil or environmental engineering?
Ooh, that's a loaded question. I'm excited about a lot of things. I'm a very easy person to impress. But as far as in the field of civil engineering is concerned, I think there's this paradigm shift that I think a lot of people are beginning to see, and that's the acceleration of innovation is growing significantly. What do I mean by that? Many people have seen all these buildings we have here in Los Angeles and all over the world. People will see these buildings as almost like old giant structures that just stay there and they don't change for centuries. Well, we're at the cusp of in civil engineering of now going into this ramp up of advanced buildings. So smart buildings, smart structures, smart infrastructure, where your car can talk to the road and the road can talk to the building and the building can talk to you a mile away. So these are the things that are becoming very, very interesting in civil engineering, and these problems are going to be solved by you all, right? So our job here is to essentially prepare you guys for that. So for instance, the idea of earthquakes. So some of the research I'm focusing on is focused on looking on having, when earthquakes happen, giving you some level of time to essentially catch up, right? So early warning, earthquake early warning, right? So when the earthquake happens, you're going to find out, you're going to have at least maybe a minimum of 20 seconds to either get out the building or go get under the table, right? These are live, real things that are going and happening right now. And it's like a big shift from traditional engineering to like this complicated system of interrelated systems, right? That's where we're going. And we're going to be teaching about that, earthquakes, tsunamis, you name it, those things happen. Going to the moon, right? People talking about moonquakes. There's a lot of things about what happens, earthquakes, and they have moonquakes now. So what do we do in the moon when there's moonquakes? How do we build these buildings in the moon for moonquakes? Do we do 3D printing? We have 3D printers here in our department that can essentially 3D print a building. How do we do that on the moon? How do we make it easier to do on the moon? So these are the things that I'm excited about. There's this whole new avenue of stuff that's coming. And I'm so excited to be here to essentially see it happen. In my lifetime, I'm going to at least see some of these things happen. And in you guys' lifetime, as students, you guys are going to see even more, right? So when I was a kid, one of the interesting things, watching Star Wars and all those fancy things and all these flyers and all these stuff, flying cars. Well, I might be around just enough to see that in fruition. You guys will be living those situations. So that's what I'm excited about. That's my side. I'm a crazy person.
And now you got people scared about moonquakes. This is the first time I've ever heard that. Was great. Adam, environmental engineering, to speak on the environment, what are you excited about in the world of environmental?
I think the most exciting topic in environmental engineering right now is probably water reuse, and that's especially important for drought-prone areas of the world, including Los Angeles. So we're located, like Buka was mentioning earlier, we're located in such a complex urban environment. So there's numerous opportunities for our students. And one of those for environmental engineers is LA is trying to increase their water security and rely less on imported water sources. So most of our water that we bring in for drinking purposes is coming from hundreds of miles away. And only about 10% of our water is local, which is crazy. And so to change that, they're trying to flip the script here and have about 2/3 of our water be sourced locally. And to do that, we have to do on a large scale water reuse, where we take our used water, treat it to very high quality drinking water standards, and then we put that back into the groundwater and then eventually extract that for drinking purposes. So I'm most excited about that, especially because it's something that is actually happening in LA in the next 10 to 15 years. And to that effect, we also this summer started a large scale research endeavor called the Rewater Center at USC that focuses exclusively on potable reuse and the different emerging technologies that can make that process more efficient and also safeguard public health.
This is great. Any other ideas? I didn't want to cut anybody else off. Something you were dying to say?
Well, I'll go back to robotic construction because that's something I'm very passionate about. Buka mentioned the 3D printing lab we're building. So these are like building scale 3D printing machines that can print up to 5,000 square feet structures. I do have a project where I'm working on teleoperation of construction equipment. So think about remote operation of all of these heavy construction equipment. Imagine being in Los Angeles, but you're operating something in New York. How do you make that happen? We have robotic arms that we're experimenting with in our labs currently. So I guess I'm mentioning this because I don't want our prospective students here think that technology and computing is far from civil and environmental engineering. Is actually quite integrated. One other example I'll give to you, Buka mentioned a little bit, is my work is in smart buildings. So I focus on how technology, through the integration of technology into the buildings, how buildings could be like machines that understand their occupants' needs, requirements, habits, and provide those services, not just being a shelter, right? But also a service-oriented environment that augments whatever takes place in that building. It could be learning, or it could be productivity-related, office productivity-related tasks, or it could be health and well-being, right? We spend 95% of our times indoors. So much happens in built environment, and I think the future is very exciting with the integration of computing methods into our research and also curriculum.
Great, thank you. I'm sorry, I just realized I sent a message to all of you, but that was to Buka. Sorry about that. Let's dive into our questions. We have a good number of questions here, and as a reminder to our audience, keep throwing questions in and keep upvoting. We got a few upvotes on some things, but I think you guys forgot to keep upvoting, so keep jumping in there for pushing things to the top, and we're going to go top to bottom as we go down here. Our first question is going to Sohom Patel, and Sohom is asking, when do we decide what section of civil or environmental we plan on majoring in? And I want to prepend this question with something I forgot to say. We're not going to do any admission questions today, nothing related to the application process. We have plenty of admission stuff, and our AMA was earlier this week, so let's keep this focus on this discipline in particular. But the reason I say this is this kind of is related to admission, and I want to make sure I do address this, but then you guys can talk about for current students. You only apply to either of these areas, it's civil or environmental, because these emphases are so different to your current student kind of progress, your evolution as you go through, as we're talking about the curriculum narrative arc that you kind of go through. So right now, don't worry about it. There's nothing you need to worry about. But as you go through the classes themselves, by working with faculty and the classes that you take and the experiences that you have and the advisors that you'll have in the department, you'll choose it. But there isn't a specific certain time or date. I wanted to make sure that I prepended that for you all, or does that handle the question?
Well, also, I think it's important to say that in your first year, you're going to be taking a lot of common classes, right? And then we have 2 introductory classes in our department, Introduction to Environmental Engineering, which is taught by maybe 6 or 7 of our environmental engineering faculty, and they give different flavors of environmental engineering. And at the same time, we also have Introduction to Civil Engineering, and there we also introduce you to different tracks and different subdisciplines of civil engineering. So I think you have plenty of time. I don't think that's something you need to focus right now, and you will have opportunity to explore different subdisciplines. But also our students orgs are very, very active right now. So those are great resources. When you come at the USC, you join a student org, they bring speakers, they have webinars, they introduce different job opportunities. So you will have plenty of time when you join, if you join USC, to explore different subdisciplines.
And just as natural as you did, you started answering the next question that already came up, which is how do internships work? What do they mainly look for? Internships are working with companies. I want to make sure everybody knows that. It's not part of your structured curriculum, but we, as an overall school, we bring hundreds and hundreds of companies onto campus to recruit you for co-ops, internships, and full-time positions after graduation. But you all want to jump, I mean, basically internships for our audience are, they're interning at all the same companies that they talked about for jobs. The first step is getting internships, creating those relationships and moving on. But is there anything else you want to talk about with internships?
I've not seen that being a problem at all. I think the problem is which internships our students will choose.
Yeah, too many opportunities.
Yeah, there are many opportunities. I think if you become a civil or environmental engineering, one thing we can guarantee you is you're not going to be jobless. There's plenty of job opportunities out there.
Absolutely. What is the average class size in civil and environmental engineering? Our question from Maddie. Maybe anecdotally from your guys' classes.
Sure, I think we have very small, it depends. I think I would have seen the largest maybe 45. But that's like one class is requirement and all of the tracks have to take it, and Roger's class is one of them. But then if you're on a specialized course, somewhere between 10 to 15, maybe 20.
Very intimate class sizes.
Yes.
Yeah, I mean, for the first class you take, the introductory courses right now, both of those classes are under 30. And so roughly somewhere between 20 to 25 students on each of these individual disciplines for the very first class that you take. And so it is very, very small. And that is true across the engineering school in general. Luca has got 2 back-to-back questions here, Luca. Let's start with the first one. What sorts of qualities make for better civil and or environmental engineers? Are there particular qualities that make people better?
It's a loaded question as well.
Curiosity.
Yeah.
I don't know. Do you guys have any answers?
I think that's a very interesting question because a better engineer is a subjective statement. Depends on who you ask, right? But in overall, the main thing you want to carry yourself is not just as an engineer, but as a person in general, is integrity, right? Integrity is kind of the forefront of what we do. If there's no integrity, then nothing else matters, right? So you want to have integrity in how you conduct yourself, and that encompasses everything else, right? Whether you're smart or whatever the case may be, as long as you have integrity, that's the best thing, because integrity will take you the whole way.
Great, thank you so much. Luca also asked the next question, which is what sort of study abroad opportunities are popular for civil engineering students? I'll give an intro to this question, but please jump in and help me out. There aren't specific study abroad programs for one major or another. And I want to make sure that that's clear. You know, it's just because you're civil doesn't mean you do these or you do those. Civil engineers, just like any other student at USC, go on a number of different programs, and engineering students across the board can go on all the university-wide programs. And we have specific engineering school programs as well. So it's not really specific. It's based on an individual decision of which country you want to go to, what works with your academic schedule in your particular semester. And we have lots of opportunities, whether that's semester exchange programs, we have Maymester programs, breaks, winter breaks, spring breaks, summer programs. There's everything in between. But do you all want to talk about, I know specifically, Burcin, do you want to talk about the very specific class in the social entrepreneurship area?
Sure. That's a very unique opportunity that is hosted in our department. It's called Engineering Design and Innovation for Global Challenges, and it is unique because it brings engineering students with non-engineering students in a 2-semester long course where we focus on really wicked problems like refugee crisis, or right now they're focusing on the war in Ukraine, but coming from engineering perspective in a multidisciplinary setting. So engineering students with business students, design students, science students, finding solutions that could be alleviate some of the stress and hardship that these people live in. But I will go back to something I think Buka said earlier. Engineers are problem solvers. So I think one of the qualities that make a good civil engineer or environmental engineer, that's I wanted to qualify a little bit the curiosity of like, how can I solve? How can I help? Right? So anyway, I diverted. I combined this question with the other question. But in that course that I mentioned, we take students to different locations. So we went to Greece, we went to Alaska. They just came back from Romania. So that gives an opportunity to students to immerse themselves in a different culture and a set of problems.
Great. Thank you so much. Luca just keeps burning it up with the questions. And as a reminder, we got 10 minutes left. Keep throwing in questions if you want them. And you got to upvote. I think we forgot to keep upvoting, folks. So get out there and upvote to push any questions you want to rise to the top, because it looks like we're running out of upvotes as we go through this. Transportation engineering is his question. What does work in this field look like as a civil engineer? It's a kind of a very specific element of an application of civil engineering.
Yeah, so I saw that question earlier. So very good question, actually. And it's one of the questions I think many questions people ask oftentimes about transition. So transition engineers there's a broad spectrum of things you can do for transition engineering. Transition engineering is very, very interdisciplinary engineering. From the basic level, the initial transition engineers were tied with geotechnical engineers, because that's what I am, and they dealt with building roads, right? So in countries or in places where the roads need to be built, transportation engineers are tasked with the job of designing and building roads, which they have to do in conjunction with a geotechnical engineer and also urban planner and land surveyor, right? So that's the transportation engineer's job. In places where there's a lot of roads, like LA, right? The job of a transportation engineer is understanding optimization and maintenance, right? And how to kind of expand the lifeline that we have in transportation, how to keep the roads better, how to manage traffic signals, dealing with all those different things. That's what transportation engineer does. And then on the other side, when you go a little bit further, is advanced transportation. So how do you deal with trains? Like for instance, in LA, we have the metro. How do you interact the metro with the buses? How do you interact the metro with the buses and the bridges? How do you interact the metro, buses, bridges, and the airport and downtown? So that's kind of what transportation engineers deal with. So it's on those three levels that they deal with stuff. So in places where they need to build new roads, they build roads. Where roads are built, they manage it. And then on the other side of it is how to essentially merge everything and make our transportation system as a global system like uniform.
Great. Thank you. Eric has our next question, which is that given that civil engineering is a very time-consuming major, how realistic is minoring or double majoring in a non-viterbi subject for urban planning, for example?
It is possible. Our curriculum is we have room, but that might mean that you might need to take extra credits, right, to fulfill the requirements of different minors. But I've seen that happen.
Yeah, I think minors are regularly happening regardless of discipline in the engineering school. Students are majoring in engineering program and minoring and still graduating in 4 years. That happens all the time. Double majoring which the definition is pursuing a second bachelor's degree on top of your first bachelor's degree, according to the catalog, is an additional 32 units of upper division coursework on top of your first degree. And so if engineering is a full 4-year degree program, that's an additional year. So if you are thinking about a second bachelor's degree, you should recognize that that's likely going to be a 5-year program. Now, I say that to manage expectations because I know students that have done it in less, but I never want to tell you, sure, you can do that, because that is more of the exception rather than the rule. That said, most high school students ask me about double majoring. Most current students minor or don't at all. So just to give you a sense of perspective, from the outside looking in, everybody wants to do multiple things, but I'm pretty sure you have, and you can, and we will gladly accept tuition from you for as long as you want to stay enrolled at USC. But I bet you have a certain job in mind and thing you want to do after this. And that degree in engineering is the process to do that. But you still can pursue these elements outside of which that's taking classes, doing a minor, or just having some fun even inside of your general education curriculum. That all exists.
I think one thing to mention, I know this was about a non-engineering minor, but we have this progressive degree program. It adds, it's kind of like 4+1. Adds 1 year to your degree, but you can start taking graduate level courses in your senior year, and then continue with 1 more year to specialize on an area. Maybe, let's say, structural engineering. So you go for N1 and specialize in an area. I think that's a pretty nice opportunity.
Yeah, progressive degree program combines your bachelor's and your master's degree in reduced time, typically 5 years. I try not to call it a 4+1 because it is not necessarily exactly that. Sometimes students do it in less. It might take longer depending on how a student started it, but it is reduced time, typically 5 years, and it combines your bachelor's and your master's degree. And you can do that across disciplines as well. So sometimes students will do that in one area in their undergrad and in another area in their graduate degree. I'm going to ask one more question, and then I want you all faculty, if there's any other closing comments you have or other particular questions you want to pull out from the bottom, I'm going to let you take control of that. But Maddie's asking, how do USC students get involved with the LA community work-wise, and are there research projects? Boogie, you're nodding, so I'm going to let you jump in.
No, I was nodding because this has to do with some of the things that we have, particularly in our department. We have the Innovate LA project. I think Professor Becerik can speak to that more. But essentially, it's a competition where we bring students together. We mix undergraduates and graduate students together to solve problems that, you can. It's a competition, so you come together, you problem solve to solve problems in the community of LA. And if you win, you actually get funding to start your own small business to solve that problem. And so it's a fascinating. But I'll let Professor Becerik mention that a bit more. But we have ways.
Yeah, so it is an effort to bring an innovation and entrepreneurship culture and spirit into our department. As Buka mentioned, each team has at least one civil or environmental engineering team member, and they focus on the 5 strategic areas that I mentioned at the very beginning of this webinar. But in the LA area, okay? So they try to find a solution in terms of urban livability for LA or transportation in LA. And it is a program that runs between October and April, where in April they have their big demo day, and we invite startup companies and investors and faculty to judge one winner. Last year we had 2 actually. They were so good that we gave a first prize and a second prize. And then from there they use their degrees and the resources on campus and the winning the prize to start their own companies. We do have a lot of research opportunities in our department. We involve our undergraduates in our labs. I think environmental engineering group is a pioneer in this area. Adam, do you want to talk about the undergrads? And Roja, you also have undergrads working with you, I know, in research.
Yeah, we have in environmental, we have plenty of undergrads that are involved in our research. Typically, these undergrads, they can start as early as their first year at USC. I have someone who's in her very first semester, and she's volunteering in the lab at this point already. Typically, it's something like 8 to 10 hours a week for the students that are really interested in research, perhaps considering graduate school after they complete their undergrad degree and seeing if research is the right path forward for them. So we give them that opportunity at USC.
Roger, do you want to talk about the undergrads?
Yeah, that's right. I have undergrads working with me since their freshman year, and they've been extremely useful and significant contributors to our research program here. And they engage as much as their schedule allows them to, and their engagement has actually grown the more they have learned and the more courses they've taken at USC. So it's a very valuable experience both to them and to me and my group as well. And it's encouraged. We have some of the best students here, and we love nothing more than to see them get better.
And also the school, the Viterbi School of Engineering has the CURve program, Center for Undergraduate Research through Viterbi Engineering. And through that, you could actually get a small scholarship to essentially conduct research. I've hosted a student or two over the last 2 years. And the course goes from essentially starting like around November all the way until May. So you get to do a year's worth of research with the faculty and also get compensated for some extent towards your school. So there are opportunities for you to do a lot of research here.
This is great. As we close out our final minutes here, is there anything else that you all have as final thoughts, or whether you see a particular question you desperately want to address? Adam, I'll start with you, if there's any other thoughts you would like to close out with.
Well, I would just like to sort of emphasize how broad environmental engineering is as a discipline. I think there's so many new exciting areas that environmental engineering is expanding into. So I think the opportunities for students in our program and to graduate with a degree in environmental engineering are so strong. The job market's incredible. You can't go wrong with environmental engineering. That's what I'll leave us with. Or civil, also good.
No, stick it. No, own environmental, man. There's plenty of people talk about civil here. Just own it. Raja, do you have any other final thoughts for our audience?
Yes. The height of your career is 20 years from now. We have no idea what you'll be dealing with, but we at USC you'll be working with the faculty who are pretty much writing the book for the next generation of civil engineering. So you will be equipped to assimilate and integrate and learn how to deal with the future of computing, the future of data, the future of science, as it pertains to systems and materials and concepts that we rely on very much in civil engineering.
Buka?
So there's two questions I want to answer, and I'll close it out. So the first question was talking about if you're into nature, what is a good subtopic for you to pick? So if you're a nature, I love nature. I'm a big nature person. You can see my picture in the background. It's from June. Nature is a thing that civil engineers deal with on consistent basis, because as civil engineers, we are the stewards. We are essentially stewards that act at the interface of the built environment and the human and the natural environment. So we have to essentially be in nature all the time. If you want to directly do in nature as a geotech, we go in the field all the time. As an environmental engineer, you also do a lot of field work all the time. So there's a lot of options for that. The other question I wanted to answer, somebody mentioned about the use of AI in civil engineering. I want to emphasize this particular point, is that there's a huge understanding or wave of AI right now. And what AI is a tool that can be used to essentially solve a lot of problems. So in civil engineering, we have a lot of problems to solve. So here, we as faculty of civil engineering at USC are what we call domain experts. So we are the experts of these problems. And the tools of AI are what we use to employ to solve these problems. So when you come to USC as civil engineering, we will teach you how to use these AI tools to solve these problems. For instance, I do a lot of work with earthquakes and natural disasters, and I deal with essentially with machine learning and AI on how to essentially characterize hazards in some ways, right? That's just one aspect of what facet that I use AI in. So there's a lot of things you can do AI in. So in that same point, civil engineers do a lot of interesting things. Everything that you interact with on a daily basis is civil engineering. You may not appreciate it for civil engineering, but it is civil engineering. Whether it's the car you drive, the brush you use, the computer you use, or the way you walk down the street, the paved walk you walk on. These are all civil engineering concepts, or civil engineering concepts were used to essentially make these things happen. The iPhone doesn't get built in the cloud. Some people think it gets built in the building with structures and things that civil engineers have to essentially construct. So we are the gatemen, the guardians of the world in some senses. So I want you to understand that, and when you come here, we're equipped with the right weapons to essentially attack all these world problems. So we'll see you soon.
Thank you. And our final thoughts and words come from our esteemed chair. Burcin, what are your final thoughts?
I don't know if I can top my colleagues' answers. I think they answered it really well. If I can just summarize it with a couple sentences, our department is very forward-looking, so it's definitely not a traditional civil and environmental engineering department, and I think you heard that from some of my colleagues' answers. We are a small department with very strong research, but also I want to brag about this, a family-like environment. We provide a lot of opportunities to our students, from innovation competition to our research symposium that we just concluded last year, to the course that I mentioned, where we take you to tackle really difficult problems, to opportunities in our research labs to write the path to the future, right? So I hope you decide to apply. I'm a little biased. My 15 years that I spent in our department, I don't think I would have changed it with anything. So it's been extremely rewarding, and I see that from students' perspective, it's similar.
Fantastic. No better words to end on. Thank you to all of our audience for being here today for our session. If you missed any part of this, the recording will be up on our YouTube page probably in about an hour. But most importantly, our thanks to our faculty panelists here, Professor Smith, Professor Becerik-Gerber, Professor Nweke, and Professor Ghanem. Thank you so much for being here. We truly appreciate your time explaining the discipline, the department, the classes, the curriculum, and the research to our prospective students. For all of our prospective students out there, do not miss the application deadline that is coming up very, very shortly. If you have any other questions, check out our website, viterbiadmission.usc.edu/apply. If you have any other things you want to attend that are happening, viterbiadmission.usc.edu/events. We have lots of other events that are going on. Thank you so much. Have a great rest of your evening. Thank you all. Bye-bye.
Bye-bye.